What if the most powerful language model prompts aren't written by humans at all, but are evolved by AI itself, becoming more complex and alien than anything we could design? Today, we're deconstructing two DeepMind papers from 2023, PromptBreeder and Self-Discover, that do exactly that. There's a Colab in the description which will help us go through from the lab to the laptop to understand how this AI self-improvement mechanism works. So this is the third in my little series on AI and evolution. Now we're moving on to self-improvement using LLMs. This takes us to kind of the end of 2023, and I'll talk about the Self-Discover paper and have a demo with a Colab which I've included in the description, and also look at one of the key elements, PromptBreeder. So the Self-Discover paper has a link here, and I've also put the link in the description, is from DeepMind. And the idea here is that LLMs should essentially identify and integrate reasoning modules within their output. Now this is before kind of the O1 and more lately Gemini Pro had kind of these reasoning or thinking tokens. Basically this is a technique to simulate the thinking process by mechanically making it happen. Now this is shown in the paper to increase performance on tasks which require reasoning, but this is not really a reinforcement learning method. This is a way to construct essentially what humans do. One of the interesting aspects is not only did they train on the internal kind of Palm models from Google, which is always kind of a telltale signal from these papers even before they were anonymously reviewed, they also looked at GPT-4 and at the time the Llama 2 70B, which was the largest open source model at the time. So this is very interesting that DeepMind would be doing this, but it also gives a huge amount of credibility that this will work on a model which people can look at much more carefully than we can look at the proprietary models. So here's a quick framework diagram from the paper, which just outlines how we've got a language model, the task which we're actually looking at, and these atomic reasoning modules. They're going to pass this through the self-discover process, and we'll actually get kind of reasoning structures coming out of this to enable the language model to essentially gauge where it's at in the reasoning process. So when we actually come to solve a problem, we're going to take a task, we're going to form a reasoning structure using the language model to get the answer. So basically this is organizing how the language model is going to approach the task, and that is something which we're explicitly going to lay out. Okay, so when we come to the actual self-discover modules, we've got three main parts. For the selection stage, basically we'll have a list of different approaches to the problem, different kind of modules that might be useful, and we'll get the language model to decide, okay, what approaches sound good. So this is kind of a selection process, which hopefully will pick out, say, 3 to 5 of the good approaches from a long list of approaches. The second stage, which is adaptation, is to take those approaches and then get the language model to flesh out how those approaches might be applied to a task, so that instead of a one-line title of the approach, it's a more kind of formal definition of what we're going to do when we apply this approach. And in the third stage, which is an implementation stage, basically we're going to say, here is the actual problem, and you've already identified the modules and how they should be used, so now go ahead and use them. And so this is where we actually get to the solution for our problem with these reasoning structures. So these are the key ideas in the paper, but let's go to a notebook so we can actually have a look at this ourselves. So what we're going to do, and I'm going to use the Colab notebook link in the description, is we're going to use the free, as in freedom, Gemma models, they're open source, from AI Studio, which is Google's free, as in dollars free, resource for accessing both the Gemini models, their proprietary models, and also Gemma models, which is super convenient and a public service from Google. Okay, I'm going to assume practically everybody has seen this already. This is aistudio.google.com. It's essentially their ChatGPT interface, but it goes more than that, in that we can actually look at lots and lots of different models. So in particular, we've got the Gemma 3 27B, which we can access just by clicking this. And okay, now I'm on to writing prompts for Gemma 27B. If we want to explore how to get a REST interface for this, we can just click this button and it shows us how to call this in code. One thing we'll need for our Colab is an API key. which if you click this button, you'll be able to get an API key, which will then give you free access up to certain kind of daily limits using any of these models from AI Studio. Hopefully everyone's familiar with this API key process. So this is what the Colab looks like. When you load it yourself, you'll need to copy it to your drive because you won't be able to alter my copy. What we will do with the API keys is we'll put in a Google API key entry here. This is what I've called it in my code. It doesn't have to be called this, we can call it whatever. And then I've actually revealed it to the notebook, which will allow the notebook to pick up the data. So this is purely within the Note environment. It's kind of reassuring that the key process is distinct from the rest of the Google ecosystem, showing you kind of how separate these pieces are, which is good from a privacy point of view. Okay, so one of the packages that we need, this Google Gen AI, seems to be installed on Colab by default, but just so if you write your own code, that's what you're going to need. And I'm then going to use this google.colab user data thing to pull in the API key. So basically all I'm doing is getting the API key, but this enables me to store the same API key for all my Colabs. This is kind of good practice. Right, so now I've got a Gen AI client. So this is a thing which essentially will pipe my requests through to AI Studio in this case. I can then have some simple code to call up the Gemma 3 27B or 12B, whatever models. Now in this I've actually found that these two models are now way better than the models in the paper, which even though it was testing on Llama 2 70B, was getting worse results than these models are now. So if we cast our minds back to 2023 when the papers were written, Llama 70B was a large model. We'd just been through that year following the release of ChatGPT the year before, and there was a huge amount of excitement around Llama, and Llama continues to be a strong open source contender. But now Google has come along, and these are also very strong models. Hopefully the open source thing keeps going with these large companies competing in the open source arena as well as their proprietary models. Next thing, we'll generate some kind of content config. In particular, I'll keep the temperature at 1 and a top P of 0.95. If you're interested in having like a deeper dive into what these things mean, leave a comment below. I'm totally happy to go in any direction here, whether it's towards the new papers or towards more code. I'm really at your beck and call. Just leave a comment, please. So then I've got a quick function which enables me to actually define all these things and just return a nice object for the response. Basically, it's wrapping the prompt, which I give it as a string, as just a single user prompt and expecting like a text return. Now at the bottom, we've got an example of it being called and actually getting the text back. Now it used to be that with the big models, the opposite of hot is cold would be all they would say. But now we've actually got some, even though this is a Gemma model, which are not actually reasoning in terms of being RL trained as far as we know, this is actually much more inclined to give an explanation. And so this is kind of an interesting, it is actually kind of hedging its bets as well as getting the answer correct in the first line. So it's interesting how these models have evolved through time. So I've got some other examples in here of the kind of questions people were interested in back in 2023. This is a GSM 8K question, like Lisa has 10 apples, she gives 3 to her friend and then buys 5 more. Okay, this is something which is actually far too easy for these models, and they get this right straight away. There's another example, this is from the paper, which talks about defining paths in SVG, the scalar vector graphics format, which is actually not that easy for humans to parse out. I believe, having drawn a few of these things, that I know the correct answer, and some of these it gets right, some of these don't, but it's actually getting way more right than it was in the paper, so this is kind of tricky. Now let's go on to this other one, which is how many ways are there to arrange the letters of the word 9? Here, it's actually getting the correct answer, but you can see it's trying to do this in several different ways. So this is something which, a small model, so this is using a 12B model, it would never have done back in 2023. Clearly this has been trained to try and, reason through a problem before giving a final answer. And in a way, this kind of boxed instruction here is like it's a clear signal that there's been some kind of reinforcement from verifiable feedback here, because boxed is a very normal format for answering questions when you're going to verify the answers. Okay, so clearly it's trying to do it's trying to get distinct ones, it's trying to enumerate them all, it's actually managed to enumerate them. This is pretty impressive for a 12B model, but unfortunately it's getting it correct. In the paper, all the models would be getting this wrong, and so hence you would need the self-discover process. Now from the paper, in the appendix, they list out the reasoning modules, which I explained were going to be used as like a selection of the different reasoning modes. So I've commented out a few of them. Basically, they're using kind of user-reflective thinking. I don't know, it's basically, I took out some kind of complicated ones. I also took out this let's think step-by-step instruction, which is such a trope these days. It's almost like a green light to these models to do what your training says. So it's kind of an unfair to give it that hint directly. I'd like to investigate what else could occur. Now you can also update this list of instructions on your own. Basically, the model is going to interpret what it's derived from this list of instructions, and it's going to use that to formulate the plans. So feel free to eliminate a whole lot of these and see what happens. So then I have a select reasoning module. So this is the first step in self-discover. Basically, I ask the model, okay, what modules would you like to solve this task? It then comes up, okay, I want a list of ideas, I want to break down. So basically, it selected 3 things that it wants to do from this list. Second was the adaptation step. So here, basically using those reasoning modules, essentially adapt them to be specific for this task. Okay, so here it comes up with a bit of how to do these things. And then we're going to move on to the third thing, is having used these adapted modules, let's implement them for this problem. And you can see here it's going through the steps for the same problem again, but we see that it's actually come up with a nice clean structure for exactly what it wants to do. And then we can execute that, essentially telling the model, okay, now just go do that. So the key thing here is self-discover has kind of got the model to plan its own demise, as it were. Basically, it's plotted out all the things it will have to do by actually asking it to explain what to do. So this is kind of a nice, in a way, a nice trick. If you just told the model, solve the problem as well as possible in one step, it would have a much harder time, or probably. But here, what we're saying is choose how you might solve a problem, now adapt it, now make it specific, now just use those instructions you just wrote. This might come as a surprise to the model, if the models were capable of surprise, because it wrote some instructions as if for a human, but is now being told to use those instructions which it just produced. Fortunately, it gets the answer right. It previously actually did know the answer, but that was the difference between the 2023 models and today's models. Things have improved a great deal anyway. Another nice thing to think about is for this list of instructions, these seem rather similar to some of the summaries that Gemini Pro will give out. Now, I'm not sure whether the initial kind of Gemini Pro reasoning was somewhat based around these ideas, and that it'd be prompted to take particular steps to do the reasoning, or whether this is just a convenient list of summaries which it can come up with easily. This is readily suggestible by Gemini, or whether there were several phases, in which case there was some reinforcement learning thing going on as well. Who knows what's going on behind the scenes? But this is definitely kind of interesting that they have this nice list of reasoning styles. So the question is, where's that coming from? So as they mentioned in the paper, the reasoning is coming, or these atoms are coming from PromptBreeder. So this is work which looks fairly concurrent, but my guess is that the teams were passing data between each other. This PromptBreeder paper, which I actually met the people presenting it at ICML last year in Vienna, basically is essentially using an evolutionary style process to improve prompts. So this is why this video fits into the evolution series, as it were, because we're now beginning to see how LLMs can be used in an evolutionary loop to improve themselves. So one interesting twist which is here is that not only does the PromptBreeder use evolutionary approach to improve prompts for tasks, it also uses them on itself to improve the improver. So this is a nice meta level at which this thing works. And it's not something which I've seen many people comment on as being like an extra special twist here. So the thing in the paper for prompt breeders, they prove that this technique works across lots of different domains. And what we find out is that these prompts, having been bred on lots of different domains, are then put into the list for the self-discover reasoning atoms. So PromptBreeder itself is a kind of two-level process. And the base level is where they will take a prompt to solve a task and then say, change the prompt so I can do better at the task. So output a prompt which will perform better. We can then measure how good that prompt is by running the task, measuring its output, like its accuracy or whatever, and that will then evaluate how good that prompt is for the task. And basically, we can keep a table, a population of these individuals, and then select which is going to be modified next to try and promote a better and better prompt as being our final output. So we can do this both on, we have a validation set, we have a testing set. We can make sure that this is kind of a robust process for these mutated prompts. But beyond that, there is another process, which is how do we actually specify how to mutate the prompt? Now, it may just be modify this prompt to give me a better answer, or it may be think about this in an innovative way and reprompt. Basically, there are lots of different ways you might prompt the mutation, and we keep that in a separate table of population of prompts about prompting. And we can also run the whole process over that. So the prompt breeder not only breeds prompts, it breeds prompts about prompts. And this meta level is something which we'll talk about in the Darwin Gödel machines next time. So this is their diagram for how it works. We can just have a direct approach to an LLM input to output, or we could say, well, we're going to use our LLM to try out a number of different prompts. We can then also say, let's try and mutate these things. We can also then say, let's try and mutate the mutator. So this is very interesting. So as I said, Appendix D shows that these thinking styles are the things which are going to be used in self-discover as the reasoning atoms. And we've also got in Appendix C the mutator prompts, which also make for interesting reading to show you what the prompts are to change the prompts. So this future direction slide is a slide which I presented early 2024 about PromptBreeder, where I said, this is a cool technique. It could be integrated into any prompting process, and we actually see this playing out today. One other interesting thing is the DSPY framework, where they do actually modify prompts if you ask it to, and that's one of its kind of key selling points, is that it would enable you to be LLM agnostic, because you can modify prompts to suit any LLM. This is something which I kind of like and would be happy to do a video on. I kind of like the DSPY framework. Please leave a comment if you'd like a video about this. It's a super interesting approach and more hands-off than some of the other orchestration frameworks. So as a wrap-up, clearly we've seen with training of these huge LLMs, huge compute can result in great results. But one of the lessons here, though, is that essentially tactically applying this compute can be better. It may be that the bitter lesson tells us we should just remove all structure and let the LLM learn for itself what to do, but still it helps to have these kind of stabilizer wheels on our bicycle of forward progress. It's also interesting to see that DeepMind was playing with Llama back in 2023, but now you can play these games too with much smaller models on kind of more consumer GPUs, or Colab itself will gladly handle, particularly with like an Unsloth LLM package, will gladly handle playing with these models for free. Colab, super nice resource from Google. I would not only look at Gemma as being, that's Google's open source models, but consider models like Qwen, also very powerful in their own right. Thank you for watching this video. I'd be super glad to read any comments you have and act on them. So if you have suggestions for what content you'd like to see, just let me know. So have a good day. Cheers.